In order to ensure that the Bitcoin blocks are mined roughly every 10 minutes, Satoshi Nakamoto implemented an algorithm that adjusts the difficulty of mining depending on how many miners are competing to discover a block at any given time. Now, this is directly related to why it is no longer profitable to mine Bitcoin with a laptop and why every time it is needed more and more powerful and expensive hardware to mine Bitcoin. Welcome to Crypto. My name is Xavi, and today I'm very happy to be delighting you with a very special video, as I will not only be telling you all you need to know about the mining difficulty adjustment, like how often it is adjusted, why it is important, or even how it is calculated, but also I will be diving with all of you into Bitcoin's code. Yes, that's right. I will show you the very real Bitcoin code and show you exactly how Satoshi Nakamoto coded the algorithm to make the difficulty adjustment possible. In fact, little spoiler, I took the little piece of code you are seeing here down below from the current Bitcoin software that is running exactly right now as you are watching this video. So make sure to stay until the end, because I will be showing stuff that literally nobody has been able to show so far in YouTube, most likely because the blockchain developers, well, they are simply too busy coding, and some YouTubers, only some of them, are too busy worrying too much about getting views and likes and worrying too little about delivering valuable content. Let's dive straight into it. Alright guys, to get started, first of all, what is all this Bitcoin mining difficulty and why do you want to know about it? Well, the Bitcoin mining difficulty, as the name implies, refers to how difficult it is for miners to solve a block using their hardware. Or in other words, how much power is needed to solve a block using mining hardware. Because the Bitcoin network is completely decentralized and not run by any single authority, an algorithm hard-coded into the source code by Bitcoin's creator Satoshi Nakamoto is used. This algorithm constantly readjusts the difficulty of the mining process in line with how many miners are operating in the network to ensure that blocks are discovered at a constant pace. The network relies entirely on a decentralized transaction validation process. Anyone in the world can take up the responsibility of validating new transactions and adding them chronologically into the blockchain via new blocks. As simple as it sounds, the whole process, known as proof of work, involves a computer-intensive effort that requires the validators to use their machines to generate a winning fixed-length code before anyone else does, which is known as finding a block. By forcing validators to expend some form of energy to discover new blocks, the idea is that it gets rid of potential bad actors from participating in the network and attempting to corrupt the blockchain with invalid transactions. To increase their odds of winning, miners over the years have started to use specialized computing equipment called application-specific integrated circuit miners, or ASIC miners, that are capable of generating over 1 quintillion random codes a second, an exponentially higher number, as you can guess, than any regular laptop is capable of producing per second. Said that, now I want to talk about why the Bitcoin mining difficulty matters or is even important at all. Well, first of all, the Bitcoin difficulty algorithm is programmed to keep the entire system stable by maintaining a 10 minutes duration for finding new blocks. Or in essence, it takes roughly 10 minutes for one miner out of the entire network to generate a winning code and win the right to propose a new block of Bitcoin transactions to be added to the blockchain. The algorithm increases or decreases the difficulty of mining Bitcoin. Whenever there is an increase of miners, or technically mining rigs, because they contribute with computational power, it increases the difficulty of mining Bitcoin. Otherwise, as there would be more computational power trying to solve a block, the block time would decrease and therefore the network would become unsafe. On the other hand, if the amount of miners competing to find new blocks decreases, the protocol reduces the mining difficulty to make it easier for the remaining miners to discover blocks. Now, said all of that and slightly jumping a bit into more specifics, the target hash is the name given to the specific hash, coded with a fixed length, that all miners are trying to get. Whoever generates a random code that happens to have an equal or higher number of zeros at the front than the target hash first is selected as the winner. Now, if anyone at that point is still wondering why the Bitcoin mining difficulty is so important, is simply because without the mining difficulty adjustment, blocks would likely be discovered faster and faster as more miners join the network, increasing the computational power of it every time with more sophisticated equipment. This would result in new Bitcoin entering circulation at an unpredictable rate, which at this point is important to highlight that a huge part of Bitcoin's advantage is its constant, predictable rate of inflation compared to the unpredictable and uncontrolled inflation of fiat currencies. Alright, but how frequent is the Bitcoin mining difficulty adjusted? Well, the Bitcoin's mining difficulty is updated every 2016 blocks, which is roughly every 2 weeks. And this is why each 2016 block interval is called the difficulty epoch, as the network determines whether the activities of miners for the last 2 weeks have reduced or increased the time it takes to mine a new block. If the time it takes is below 10 minutes, the mining difficulty will be increased, and the opposite will happen when the block time is above 10 minutes. Alright guys, so far we have talked about why it is so important, the mining difficulty, and also about how frequent it is adjusted. So now it's time to talk about how is the Bitcoin mining difficulty calculated. Well, the Bitcoin mining difficulty is calculated by dividing the difficulty target by the current target. By the way, note that the difficulty target is a hexadecimal notation of the target hash, whose mining difficulty is 1. In contrast, the current target is the target hash of the most recent block of transactions. So basically, when the two values are divided, it yields a whole number, which is the difficulty level of mining Bitcoin. Now, for instance, if the answer is 30 trillion, then a miner is expected to generate approximately 30 trillion hashes before it can find the winning hash. Of course, sometimes miners can get lucky and find it within significantly fewer guesses. The mining difficulty adjustments are made by comparing the standard time it should take to find 2016 blocks of transactions on the Bitcoin network to the time it took to find the last 2016 blocks. Keep in mind that the accepted block time is 10 minutes, and therefore the expected time for mining 2016 blocks is 20,160 minutes, which is approximately 14 days. So the network calculates the total time it takes to mine the last 2016 blocks. The ratio of the standard 20,160 minutes, which is 10 minutes times 2016 blocks, to the time it took to scale the last difficulty epoch is then multiplied by the most recent difficulty level. The calculation yields a result that will determine the required percentage of change in the mining difficulty that will bring the block time to the desired 10 minutes. So while a 10-minute block time is the goal, the mining difficulty cannot be changed above or below 4 times the current difficulty level. The upper limit for each difficulty epoch is a positive 300% change, while the lower is a minus 75% change. This rule is put in place to eliminate any abrupt changes in the mining difficulty. And by the way, for all of you that are curious about what are these lines of code you are seeing right now on the screen, they are the very same lines of code that Satoshi Nakamoto wrote to limit the adjustment step of the mining difficulty adjustment. Now, all that information is very interesting, but how does the code to implement that actually looks like? Well, we are getting very close to dive into the Bitcoin running code. So guys, things are about to get nerdy, but not too much, as you are not expected to know how to code to watch this video. So the idea is just and simply to show you where and how they are implemented, all the different parts of the mining difficulty adjustment in a very high level, so you get to see how transparent Bitcoin is. Said that, the pieces of code you are seeing right now are from the actual running code of the Bitcoin network. There are 4 files that I will be briefly looking into to show you exactly how the mining difficulty adjustment algorithm is implemented. I will only look a bit in these 4 different files, which are the chain parameters, the blockchain, the mining, and the proof of work.c++ files. These 4 files are part of the source code of the Bitcoin blockchain code and are programmed using the programming language called C++. Alright guys, as I promised you at the beginning of the video, I'm looking at the very same code of the Bitcoin blockchain that is running right now. In fact, right now I'm looking at the chain params.c++ file, which, as I mentioned, is part of the source code of Bitcoin, and it is where the chain parameters are coded and defined. I'm obviously not going to go through the whole file, that wouldn't make any sense in this video, but I just want to show you a part of it that is related to the difficulty adjustments. So just scrolling down a bit on the file, here we find the main network parameters about the consensus mechanism. So as you can see here, they are defined inside this public function all the way down here. However, I'm not gonna go through all of them. In fact, most of them probably will sound like Chinese to most of you. So no worries about it. I'm just gonna show you 3 lines of the code that I think they are fairly straightforward, which are lines 77, 78, and 82 that I have highlighted with a dark blue background and white color of the content. So the first one I want to talk about is the proof of work target time span, targeted for 2 weeks or 14 days, but then converted to seconds. As you can see here, 14 days times 24 hours per day times 60 minutes per hour times 60 seconds per minute. It's the way how it is converted, 14 days to seconds. The next line I want to talk about is line 78, which is the proof of work target spacing, or in other words, how often should blocks ideally be found, which, as we already discussed previously in this video, is 10 minutes. And here once again they convert these 10 minutes to seconds. Now you probably guys have always heard someone saying, hey, the difficulty adjustment is every 2 weeks, and then the very technical guy would jump and say, well, actually it's every 2016 blocks. Well, as you can see here in line 82, it is true that it is every 2016 blocks, but this number comes from dividing the proof of work target time span by the proof of work target spacing. So the binding difficulty is adjusted every 2016 blocks, which comes from dividing how often the difficulty should be checked by how often a block should ideally be produced, which is exactly as dividing this number by this number. Now, the next file I want to show you is the one called blockchain.c++. If we scroll down to line 409, here we have a function definition called getDifficulty, which is, as you can see here in the last line of code, it returns the difficulty as a multiple of the minimum difficulty. By the way, I just wanted to emphasize that you are seeing the codes of line that Satoshi Nakamoto wrote. Like really, as you are behind the screen watching this, he was also behind the screen, but instead of watching, he was coding it. Isn't it very impressive to be able to see how a $500 billion asset software looks like? I mean, we have access to every single line of the code that executes all our transactions and keeps safe and running a whole financial system that moves billions of dollars a day. Anyway, now we are going to have a quick look at the file called mining.c++, which, as the name explains, defines the different functions related to the Bitcoin mining process. Now, if we scroll just a bit down, you can see here between line 56 and 92 a function called getNetworkHashPS, which stands per second. So basically get network hash per second, which among other things uses functions like the get difficulty adjustment interval here in line 68, or the function get block time here in line 75. But once again, the idea here is not to analyze line by line all this code. I just want to show you a bit how the relevant functions for the mining difficulty adjustment, what do the functions take, what do they do inside of them, or what do they return when they are called in some other parts of the blockchain code. So just to summarize this function, as you can see here, it returns the ratio between the work difference and the time difference. So whenever Satoshi Nakamoto would want to make use of all this code inside here, but somewhere else in the Bitcoin code, it would simply call this function, and then the function will return the ratio between the work difference and the time difference. Also within the same file, if we scroll just a bit down towards line 413, there is a function called getMiningInfo, which, as the name implies, the function returns different mining parameters like the block weight, the network difficulty, or hashes per second, among other parameters. Said that, the last file I will be showing you is the one called proofofwork.c++. It is a very short file. As you can see here, it only has 91 lines of code. But anyway, what I want to show you here is a function called the getNextWorkRequired, which, simplifying it, it returns a call to the function named calculateNextWorkRequired that is defined right here down below. And when it returns the function, it also passes to it as an argument the block time, or actually, if we are specific, it passes to it a call to a function to obtain the block time. But anyway, it passes it among other parameters. Now guys, I know there is a lot of code, and for those who are not very familiar seeing code or not seeing it at all might be slightly confused. So again, the idea of showing you parts of the Bitcoin code today was to show you how all the concepts we know about the adjustment difficulty that we've been covering in the first part of the video are actually implemented in the code. So the only thing that I want to highlight of this file here is how the adjustments limit that we previously talked in this video are implemented in the code. So I mentioned before that the difficulty cannot be changed above or below 4 times the current difficulty level, being the upper limit a positive 300% change and the lower limit a minus 75% change. So basically this is implemented right here between line 55 and 59. So basically what it does is to check whether the actual time span is more than 75% below the target time span, and if it is, it changes it to only 75%, or in other words, it limits it. And in case the actual time span is more than 4 times times the target time span, it limits it to 4 times it. So guys, basically these 4 lines of code make sure to eliminate any abrupt changes in the mining difficulty. And as you can see here, it's actually not even complicated code. It uses one of the simplest statements when you learn how to program, which is the if statement. So if I would talk out loud this function, it could be translated as if whatever it is inside the parentheses happens, then execute this. However, if this condition is not true, it's not gonna be executed. It's gonna go to the next line of code here, and then it's gonna do exactly the same. Alright guys, that's everything I wanted to explain and show to you regarding the Bitcoin mining difficulty adjustment. I hope you liked that we started learning all the concepts related to it, and then little by little we started diving more into the technicals, ending up seeing how Satoshi Nakamoto implemented the Bitcoin mining difficulty adjustment into the current running code of Bitcoin. I also hope you enjoyed as much as I did diving straight into the current running code of Bitcoin. And hey, I know it was quite technical, so I want to encourage you to go back to the parts of the video that you didn't fully understand and really just take your time and watch them as many times as you need, as I know it might take a little bit of more time to understand and also appreciate the more technical part of this video. Also, I would love to be answering all the questions all of you may have, so feel free to leave them down below in the comments. I will be answering every single one of them. And hey, if you like this kind of content, please also let me know down below in the comments so I will continue making this kind of content. Otherwise, if there is another type of content you would like me to see, also feel free to suggest it and I will be covering it as soon as possible. Said that, press the like and subscribe button and make sure to have the notifications on for my channel to not miss my content that I would honestly consider quite unique out there in YouTube, as so far I haven't really seen anyone talking about cryptocurrencies and blockchain with such a level of detail. I mean, we couldn't get more into details as diving literally into the Bitcoin code to see how such a critical part of the consensus as it is the Bitcoin mining difficulty adjustment is implemented in the code. So again, I would very much appreciate if you would go down below in the comments and let me know what do you think about this video, and also feel free to drop a like if you like this content, so that way you're gonna let me know that you like this content, so then I will continue making it so we can all of us learn together. That's all you need to know. I'll see you in the next one.